Hello and welcome to this video on Intro to Stata on the AU Virtual Applications and Desktop. This is part of our Workshops on Demand series for CTRL. So for this workshop series, we're going to cover how to import data onto the AU Virtual Applications and Desktop system. We're going to provide an overview of the Stata environment, go over how to edit and recode data, and create some different variables. We run some different statistical tests, create some visualizations, and I'm going to show you how to export output out of the AU Virtual Applications desktop system and onto your AU OneDrive. That way you can access it locally. So in video one, we're going to specifically talk about how to load data into Stata through the AU Virtual Applications and desktop system. We'll provide an overview of the scenario, an overview of the Stata environment, how to create a log file, and obtain descriptive statistics. So I'm going to go ahead and get out of this presentation. So I already have my OneDrive open through office.com, signing in with my AU credentials. And what I'm going to do now is I'm going to go ahead and take the cs.dta. So a DTA file is a Stata data file, and a do file is essentially the syntax or the script to be able to run the different analyses and recode things. So I'm going to go ahead and add those in there. And just going ahead and checking. So we have our CS data set. And if I scroll down, let me go ahead and just double check. Oh, there it is. It was at the top of the screen. Okay, so now what I'm going to do is I'm going to go ahead and launch the AU Virtual Applications and Desktops. If you don't have this configured already, then you'll want to go ahead and see the other video sets on this. And I'm going to go ahead and run it through the Virtual Lab desktop. That way, in case there's any issues with having it connect to the OneDrive, this way you can go ahead and just drag and drop the files to the virtual desktop on the Azure cloud system. I'm going to go ahead and click on this. Going to go ahead and sign in. And also do the two-factor authentication. Okay. Once that's loaded, we have a virtual desktop. Now you can store files here as well. However, you do want to make sure though that you have it saved on your OneDrive just as backups. You don't want to keep things in the downloads because that does get wiped. And if it gets wiped, we can't recover. So we see a bunch of different files there. So I'm going to go ahead now and I'm going to open up a browser. And just waiting for it to finish. It takes a little bit of time to boot up. Let me try Mozilla. Okay, so I'm going to go ahead and go to office.com. And I'm going to go ahead and I'm going to sign in using my AU credentials. And then again, two-factor authentication. I'm going to go ahead and click on the OneDrive icon. And I'm just going to go ahead and sort by modify, or let's do the modified times the newer to older. And if this is your first time using the system, if you have a lot of files in your OneDrive, just be prepared that it might take a while for it to sync. I'm going to go ahead now and download these two. And I'm going to put these onto my desktop. So we have our intro to stata.do in our cs.dta file. Now notice how it's trying to open these up with a browser, so that's not going to work. So instead what we're going to do is we're going to now open up Stata. So I'm going to scroll in the start menu. So again, going to start, find Stata 16 and launch Stata 16 IC. Now we do not have SE or MP on the virtual lab desktops and applications. However, if you need to use like something that can handle larger ones, I would recommend using the high performance computer instead. This is not meant for really large data sets. So now now that we have Stata open, we're going to go ahead and we're going to open up the do file. So first thing I'm going to do is I'm going to go to File, Open, and I'm just going to click on Intro to Stata. So this is a do file. Whenever we see an asterisk and see how this is green here, this is telling Stata that this is a comment. So it's really good practice to save all of your comments and all of your commands into a file. This way, when you go to run stuff, it makes it easier to if you have to rerun stuff, make any changes, you have a complete log. And also annotating this and adding notes makes it easier for reproducibility and for sharing this with other researchers. So let's go ahead and talk a little bit about the scenario. So for this scenario, we're interested in studying the relationship between the amount of perceived corruption in a country and the quality of their economy. For this question, we're actually lucky that data already exists. We'll be using the World Development Indicators, which is compiled annually by the World Bank. We're using data from a previous year, and we really simplified the data set. But you can actually find the full data set by going to the World Bank data set. Or if you open up there's also a corresponding Word document PDF of this tutorial. There's also a hyperlink in there if you're interested in that data set or other data sets. World Bank makes it really easy to access their data and to open this in Stata and other programs. So often when you find a data set, for example, like old census data, it can take a lot of effort to transform the data into a usable format. And of course, there's never any guarantee that someone else has created the data set that you want to specifically use in advance. Often the first step in a research project is spending a long time looking into the values and the variables that are needed to create the data set that you need for the specific research questions that you have. So within the World Development Indicator dataset, we're going to focus on two specific variables, corrupt and GDPPC. Corrupt is an index of perceived corruption within a country's government. Citizens are surveyed and asked questions like, would you need to plan bribes to start a local business? Please note, though, that corrupt is actually what's called reverse coded. So higher scores mean lower perceived corruption. We're going to flip that in a little bit, though. The second variable is gross domestic product per capita, which indicates how well the economy is doing scaled for the population size of a country. For example, it might not be very interesting to note that Botswana produces less than Brazil overall, but it might be interesting to know that Botswana produces more per citizen than Brazil in 2014. Note that in using these variables from the WDI dataset, we are given over the responsibility of determining what corruption is and what quality of economy means to the World Bank. We've also allowed dynamic concepts to become simple numbers. However, this allows us to move quickly into later stage of analysis, which has its own advantages. So that's our scenario that we'll be using today. So I'm going to go ahead and minimize the do file for now. Let's talk a little bit about this interface. So there are a drop-down that you can use when you're first learning Stata. So it is fairly robust, has a lot of different options. And there's also some other options too for graph. We'll be doing everything through syntax. That way we have record of it. If we went ahead and did some of the syntax here it'd print out it within this, but it won't actually copy into our do file or our syntax page. You could potentially click on it and then copy it and put it into the syntax, but the syntax is much more flexible than any sort of dropdown. So on this history panel, this is going to show you all the previous commands that you've run. Whenever you run a command, you can either type out the command here or the syntax here, and then press enter or return, or you can run the syntax. It's going to print out your syntax here, followed by any results. Like if it's a table, if it's a visual, if it's an analysis, if it's actually a visual or figure, it's going to pop up in a separate window. And it can only have one window open up at a time for figures. But you would see the syntax for that. When we import a data set, we're going to see a preview mode here that'll list the names of the specific variables and then labels. And labels are kind of just a way of providing more context what those specific variables are. And we have variable types here. So what I'm going to go ahead and do now is I'm going to go ahead and show you how to set a working directory to make sure that Stata is pointing in the same location as where our data set is. So to do that, you could use the syntax. I'm going to show you how to do an initial one. That way to make sure you have the right path. So I'm going to go to File, Change Working Directory. I'm going to click on my username here, and I'm going to click on Desktop, and then click on OK. So now I've told Stata my working directory, where I'll be working out of, where the files live, is going to be this file path. That's the file path. So OneDrive American University /desktop, that's using the AU virtual applications and desktops. That's the file path of where these files live. Now what then I can do is I can go over to my syntax, and let me go ahead and paste it here. It's the same thing for the CD for the file path. Let me make a quick change here because that's actually importing the data set. So small little change I need to make there. Let me go ahead and save that for later. So with a little bit more with the syntax, now that we have that, we set our directory. Whenever you see green, that's a comment. So a command, so if we went to unclear, that's going to go ahead, and if we had a data set open, that's going to go ahead and remove it. So if you wanted to double check the file path, you can also right click on the file, click on properties, and there is our location or our file path that we can also copy in and use the syntax instead. So as with any statistical program, there's always multiple ways to do the same thing. So now what we can do is, since we've already run this, I can go ahead and I can highlight the line, and then you want to click on this execute selection icon. Now it's going to say invalid because we've already set our working directory. So we'll just let that be. So what I'm going to do now is, you can also have comments in the same line of code, but you need to have 2 slashes first. So what's really helpful too is creating what's called a log. Oh, and if you need to create a new do file, what you'll do is you'll go to users, window, do file, new do file editor, and I'll create a new syntax one. We already opened up an existing one though, so that's how you can open up a new one. There's also other options, like if you wanted to change the preferences, you can change different things, like you can change overall colors to dark mode and whatever you would like. So it's really flexible in that respect. So we go ahead and split screen this a little bit. I'm just gonna, you can see the history so far, and if it's red like that, that means there was an error. And that's because I already set the same working directory and trying to do that again. So I'm gonna go ahead and just remove that for now, just to give a little bit more space. Okay, so what's really helpful too is creating a log. A log is essentially a way of keeping track of all the commands that you're running and all the results. So what I'm going to do now is going to run 18, 19, and 20. We're going to create a new file called stata_log. And whenever we run a command, either in this command here or in the syntax, it's essentially adding it to a log file. Think of it as just a paper trail of everything we're running. So I'm going to go ahead and do that. So now we say, okay, it started the log. If I go ahead and move this, we now have a txt file called stata.tor. And as we run stuff, it's going to go ahead and print there. Since we've already set our working directory, I'm going to go ahead and use the use parentheses cs.eta. I'm just saying what the file is, and then saying if I already have a file open, we're using clear. So this is an option. So a comma means it gives you options that you can put afterwards. You only can have one comma per line, but you can have multiple options. I'm going to go ahead and highlight and run line 25. And now we can see our data set. So let me go ahead and make this a little bit bigger. So we have our variable names. These are corruption index. You can also, if you want just to browse the data or view the data, you can go ahead and look at this. So we have our country names, which is a string variable. And then we also have whether or not they're an OECD member. So we have a variable or a value label. So if it's coded as a 0, or the value is 0, the label associated with it is not an OECD member. Whereas if they are an OECD member, it's a 1, but we have a variable or a value label over that. And the same thing with free as well. So we have our corruption, our corrupt, and our GDPPC as well. And whenever you have a dot, that means that there's missing data. Now, missing data can be a really complex topic. Stata has a lot of ways of handling missing data, but that's outside of the scope of this tutorial. If you need to edit your data, there's also the data editor option. And I'm going to go ahead and click on corruption within the editor. And if I click here, I can go ahead and perceived corruption index. And I'm going to go ahead and do that. And now it went ahead and updated the label. That way, if you wanted to add more context to it, you can also do that. If you also wanted to look at a specific variable, let's say I wanted to look at corrupt, it's going to go ahead and pull that one up. Or it can also do and kind of search for that as well. Since it's a small data set, we don't have to worry about that too much. Okay, so let's go ahead and run some descriptive statistics. So when you first start out with this, what you can do is you can use describe. Let me go ahead and move this over. If the window here for the results panel is really small, it's going to kind of truncate things a bit. So with describe, that's going to tell you the variable name, the types. This is a string variable. We have doubles. So it has a decimal point with this associated with some of these. So if I go ahead and, yes, we have some decimal points there. We have our value labels. It's going to print what 1 is for that, as well as our variable labels here. And it's also saying that we've changed the data set since it's last been saved. If you wanted to get a summary, rather than typing out the whole word summary, you can type in the first few letters, and Stata is clever enough to figure, oh, you want a summary. So if I wanted just 2 variables of corrupt and GDPPC, I can just say sum, and then the 2 variables of interest. If I do that, that's going to give us our number of observations that have data, our mean, our standard deviation, as well as our minimum and maximum values. You can also add a comment here and do detail, and that's going to give you much more information. So rather than just the mean, number of observations, standard deviation, minimum, maximum, we can get our percentiles. 50%, that's our median. We have our mean standard deviation as well as variance, skewness, and kurtosis. We have that for both of those variables. It gives you a little bit more information. We can also do things like use a code book. So the code book is going to give you the amount of missingness, our percentiles again, our ranges, the number of unique values within this. So we only have 59 unique. So that's because some of the countries have the same corruption scores. That's numeric and double because it has a decimal. We can also do things like tab, which is short for table. That's going to give us a frequency table. So I'm curious about how many countries are either an OECD member or not. So again, not is a 0. This is a 1, but it's going to print out the value labels since we have that in there. We can look at our frequencies and our percentages. Now, the cumulative isn't going to be that useful as it's just adding up the percentages. So you're really going to focus on the variables here, in which values, the frequency, and the percentages. You can probably ignore the cumulative one. We can also do a cross tab with 2 grouping variables. So we would have whether or not they're an OECD member, as well as Muslim majority population. We can see the breakdown there. If we're curious what this one country is, oh, actually, I'm kind of jumping the gun a little bit. So when you did that browse, clicking here, in Stata, again, there's multiple ways of doing this. Let's say I only wanted to look at the data, but only these 3 variables rather than the whole data set. I can say browse. I want the country variable, corrupt, and GDPPC. And that will go ahead and give us a truncated version. Note this is not saving it, it's just went ahead and selected it. You can also do the same thing here and select and unselect. So again, multiple ways to do the same exact thing. Now again, if you're curious what that one country is, we can use an if command and look at subsets. So we're using browse if the country is equals 1 for OECD, so that they are a member, and Muslim equals 1, they are a Muslim majority country. So if both of these conditions are met, go ahead and show me the data. So if I highlight in one line 46, that's going to show us Turkey. So it's a really quick way to run queries. We can also go ahead and do things like take the log of a variable. Just double checking, making sure I'm not missing anything. Okay, yeah. So oftentimes, if we're interested in how a percentage change in one variable affected another, we might want to usually take the log of that variable. So now we're going to take the log of GDPPC, or gross domestic product per capita. So for gen, that's saying generate. We want to say what the new variable name is going to be, and then that's going to be calculated by taking the log of GDPPC. So again, we're generating a new variable, and how we're doing that is we're taking the log of GDPPC. When I do that, saying, okay, it's generated, there's 43 missing. That's because we had 43 missing for GDPPC. I'm going to go ahead and click on Browse. And whenever you create a new variable, it's always going to be the last one in the data set. So now if we can see that, okay, we've now taken the log of GDPPC. I can go ahead into here, and let me go ahead into the editor mode. And now I can go ahead and take log of GDPPC and just add another label to it. And I'm going to go ahead and close that. So this is actually, when I did the by hand, this is the syntax to then if you wanted to use variable label log, you can do the same thing there. And then that will also change the specific or the label for the variable. Let's go ahead and do a table for corrupt before we did summary. Now this is going to run a frequency table on every single one. So this is really not all that meaningful. So for a frequency table on a continuous variable, again, it's not useful. So we might want to then kind of truncate this, or essentially what's called binning or discretizing a continuous variable into like high, medium, and low. If we again wanted to kind of just look at just descriptives, we could use describe, or sorry, not describe, we can use sum or codebook. Describe gives you the structure instead. So what we're going to do now is we actually need to reverse code corruption so that higher scores will indicate higher levels of corruption. So to do that, I'm going to say, okay, gen corrupt 2 equals 10 minus corruption. So if they had a 9, 10 minus 9, that's going to go flip to 1. 10 minus 8 is not going to be a 2, and so forth. So we can actually see within, go ahead and just do sum corrupt detail. Oops. It is sensitive to the name. There we go. Okay, so 9.6, just looking at the largest value. So we can go ahead and flip this. So if it has a 10, it's going to be now a 0. So I'm going to go ahead and run gen corrupt2. And a good way to check this is just to open up the data set and compare. Okay, so if they had a 2.5 before, so 10 minus 2.5, they should have a 7.5. We can see that went ahead and it flipped. You should be able to add both of these up to equal 10. And now we know it should be flipped based on the minimum maximum of this variable. Great. So now let's say that we wanted to, rather than looking at this in terms of it as a continuous variable, we wanted to group these by the way of how we're conceptualizing it as like a low, a medium, or high corruption country. Now, when you bin this, though, we are treating everything within those ranges as the same, so we do lose some variability with this. So what we're going to do now is we're actually going to go ahead and recode our corrupt2. So we're telling Stata, okay, I want to recode this variable. And if it's between a 0 and a 3.3, give it a 1. And we're going to call that a low. So we're giving it a value label, and that's the value. So now we're going to say, okay, between 3.31 and 6.66, give it a 2. And that value label is going to be a medium. Our third bin, or our third bucket, is going to be a 6.67 to 10, because it's going from a 0 to 10. So if they have anything between that range, we're going to give that country a 3, and then the value label is going to be high. And then we're adding a comment saying, okay, I want you to generate a new variable with this. We're calling that corrupt categ for corrupt categorized. So I'm going to go ahead and run this. I'm going to go ahead and then run value label. And I'm just going to go ahead and just like we did before, rather than typing it out, I'm just using the syntax for this. And now I can use tab corrupt categ to take a look at our low, medium, and high countries. This is based on the data. And notice how we have unequal splits. That's because we've used equal bin sizes rather than equal sets of the data. Okay, that's going to end this first video. We're going to go ahead and start video 2 in a couple of seconds.